Okay, for chapter 15.5 notes, we're going over complex fractions. So last time we talked about rational expressions, and this is just a continuation of that. So just two different ways that we can solve these complex fractions, or in other words, these rational expressions. Same thing. So we're going to go over two methods. The first method to simplify complex fractions. First, defining a complex fraction. It's an expression containing one or more fractions in the numerator, denominator, or both. For example, we have 1 over AB, all divided by 2 over B. So two fractions being divided. The first method we're going to go over is very similar to what we did last notes. We are going to see if the numerator can simplify, then we're seeing if the denominator can simplify, and then we're turning this into a division problem and then getting our answer. So that's the first method, very similar to the notes we did last week. Okay, so looking at example 1, we have 1 over AB divided by 2 over B. So remember we said we take this middle bar here and we rewrite that as a division sign. So this is 1 over AB divided by 2 over B. Okay. Since we're dividing two fractions, what are we going to do to that second fraction? Flip it. And when we do that, it turns into multiplication. So we have 1 over AB times B over 2, because we flipped that second fraction. Since we're dealing with multiplication and division, we don't have to try to get any common denominator. We're just going to see if anything can cancel. So looking from top to bottom on each fraction, can anything cancel from top to bottom? Can anything cancel in the diagonal? Yep, just the B. So that means we're left with 1 over A times 2, which we would just write as 2A. So here we simplified 1 over AB divided by 2 over B, and we got 1 over 2A. So again, very repetitive of what we did last week. And that's if we're multiplying or dividing these fractions. So let's look at number 2. And notice that on number 2, we're doing not only that multiplying and dividing, we have addition and subtraction. So what we're going to do first is we're going to simplify the numerator and then simplify the denominator. So we're simplifying the numerator first. So we have 1 over x plus 1 over y. In order to add these fractions, we need to have a what? Common denominator. And what would be the common denominator between x and y? Good, xy. So that means we would multiply the first fraction by what variable? Y. So multiplying this one by y. And what about the second one? By x. When I do that, I'm left with xy on the bottom, or yx. Same thing. So I'm left with xy on the bottom of each one. And then what's left on the top of the first fraction? Y times 1 is y, and 1 times x is x. So if I was to simplify this, I have y plus x over xy. Okay, so that's my first step. I simplified the numerator into one fraction. Now I'm going to do the same thing to the denominator. I'm going to simplify that into one fraction. So I have x minus y squared over x. Before I can start simplifying these fractions, I need to turn x into a fraction. How do I do that? Good. X over 1. So that means I have the denominators 1 and x. So what would be my common denominator?
X.
Good, x. So that means I'm just multiplying that first fraction by x. Do I need to multiply anything by the second fraction? No, because then I'll get x as my common denominator. So I have x and then x. On the top of the first fraction, I have x times x, which is x squared, and I have minus that y squared. So that means on my denominator, I have x squared minus y squared over x. And that's my new denominator. Okay. So now if I was to rewrite this problem, I would have a fraction, y plus x over xy, divided by another fraction, x squared minus y squared over x. Now that I have a fraction divided by a fraction, what am I going to do to this part right here? Because this is the bar that's separating my two fractions, and what does that bar represent? Division. So this is now, so I'm turning that to division. So this is going to be y plus x over xy divided by x squared minus y squared over x. All I did was take this large fraction and turn it into a fraction divided by another fraction. So when I do this, what do I need to do to that second fraction and turn it into multiplication? Good, I need to flip it. So then I have y plus x over xy times x over x squared minus y squared. Okay. Looking at these two fractions, is there any part on either fraction that could be simplified further?
Yes.
Which part?
The x squared minus y squared.
Good, the x squared minus y squared, because that can be turned into a what?
Perfect square.
It's a perfect square, so we can be a factor. So that means the factor of x squared minus y squared is going to be x plus y, and what else? X minus y. So that x squared minus y squared turned into x plus y, x minus y. This is important to do because we notice now that what can cancel on the diagonal?
X plus y.
Good, this x plus y and y plus x. Why can we cancel them even though the variables are in opposite spots? Because it's adding. Good. Looking at the other diagonal, can anything cancel?
The x.
The x. So that means now we are left with nothing on the top for both fractions. So that means we write a 1 because that y plus x and that x got canceled out. What do we have left on the bottom? Y times x minus y. Good. So this right here is our answer. So for these type of problems, we can't automatically go to this step here until both our numerator and our denominator are as simplified as possible. So in this case, we had to get a common denominator. Any questions so far? Okay. Now let's look at number 3. Yes.
I missed this when I was taking notes.
Sorry?
I missed this when I was taking notes. Where you have x times x over 1 minus y squared over x. You just multiply on that side by x.
So what part are we?
The second part.
This part right here?
Yeah.
Yes, we're only you're multiplying this fraction by x because the common denominator between 1 and x would be x. So that means only this fraction's missing the x on the bottom.
Okay, so you don't have to do both sides.
No, I mean technically we are doing the other side, we're just multiplying it by 1.
Oh,
And that's why I didn't write anything because that's not going to change it.
okay.
Awesome. Any other questions? Okay. So number 3 is the last example for this first concept. So what do we have to do first? Simplify which part? The top. So we're simplifying the top first. So on the top we have potentially 3 fractions, but how can I turn that 1 into a fraction? 1 over 1. So I have 1 over 1 plus 3 over 4 minus 1 over 6. What's the common denominator between 1, 4, and 6? 12. So if 12 is my common denominator, what do I need to multiply the first fraction by? 12. What about the second fraction? 3, because I want 12 on the bottom. And what about the last fraction? 2. So when I do that, I'm left with 12 over 12 plus 9 over 12, because 3 times 3, minus 2 over 12. And now that I have all my denominators the same, I can just simplify the numerators. So what's 12 plus 9 minus 2? 19. So we have 19 over 12. Okay, so that is our new numerator. What's our next step? Simplify the bottom. Okay, so we have 1/2 plus 1/3. What would be the common denominator between 2 and 3? 6. So what do we need to multiply the first fraction by? 3. What about the next fraction? 2. So that means we have 3 over 6 plus 2 over 6, which gives us 5 over 6. So now that I have my numerator and my denominator simplified, what is my next step?
You plug it in.
Good, I'm going to replace what I simplified back into my my fraction. So I have 19 over 12 divided by 5 over 6. Okay, what's my next step? Good, so I changed this into division. So I have 19 over 12 divided by 5 over 6. Now what? Flip my second fraction. And then it turns the operation into multiplication. So I have 19 over 12 times 6 over 5. What's my next step?
Simplify if possible.
Simplify if possible. So looking at each individual fraction, can I simplify that?
No.
No. Can I simplify on either diagonal?
Yes.
Good. I could simplify this 12 and the 6. And what would the 12 become? And what would the 6? 1. So that means if I multiply across, I have 19 over 10. And that's my answer. Okay, and I didn't simplify on the other diagonal because 19 and 5 can't simplify. So once you do this step where you're simplifying everything, whatever answer you get here should be as simplified as possible. Because can we simplify 19 over 10? No. This is as simplified as it can get. If you're still able to simplify when you get to the answer, you probably just missed something. Just go ahead and simplify it from that fraction. And just make sure you're circling your answer that is as simplified as possible. Any questions on this first method? So this method was all about simplifying the numerator and the denominator, getting common denominators, and then plugging it back into that larger fraction. This is method 1. Okay. Method 2, in method 2, we are going to first multiply everything in these fractions by a common denominator. So when we do that, we get rid of all the fractions all at once. Okay? So looking at number 3, I think I labeled this wrong. Well, number 3. Notice that we did this problem above. Okay? And when we did this problem, we simplified the numerator and denominator separately. What we're going to do now is we are going to look at all the denominators. So this 1 technically is over 1. So that means we are looking at the denominator 1, 4, 6, 2, and 3. What's the common denominator between all of those numbers? 12. So we are going to take every fraction all at once, and we are going to multiply it by whatever number is going to give us 12. So that means that first fraction, that 1 over 1, is going to be multiplied by 12. What about the second fraction? 3, because we want it to be 12. What about the third fraction? Okay, the 1/2 on the bottom. And then the 1/3? 4. Okay. So I'm trying to get all of the fractions to have the common denominator right away. So when I simplify this, I get 12 over 12 plus 9 over 12 minus 2 over 12, okay, all over 6 over 12 plus 4 over 12. Okay. Once I have everything over the common denominator, I can cancel out every single one of those 12s. Because now they all have the common denominator. So that means what I have left is 12 plus 9 minus 2 over 6 plus 4. And we said that 12 plus 9 minus 2 is what number?
19.
And then 6 plus 4? 10. So notice how we got the same exact answer. So this was, let me see if I can fit it on one page. No, I can't. This is the one that we did here. Same problem, but using method 1. And this is the problem we did here. Same problem, but using method 2. You're going to choose to use whatever method you think is easiest. Okay. So remember, in this method, we're multiplying everything right away by that common denominator. And once we have everything with a common denominator, it can cancel. So let's look at number 6, right below it. We need to first make sure that everything in the numerator and the denominator is written as a fraction. The only one that's not written as a fraction is what? X. So we need to write x over 1. So now we're looking at all the denominators, x, y, 1x. And what would be the common denominator between all 4 fractions?
XY.
xy. So if we want all the denominators to be xy, what are we going to do to that top fraction?
Multiply by y.
Y, good, because we want xy. What about the second fraction?
X.
X. Remember, we're trying to get xy on the bottom. What about this, the fraction on the bottom, the first one?
XY.
xy, because notice it doesn't have anything. It only has a 1, so we have to multiply it by xy. And then the last fraction, y. Because we want it to have that xy. So if I was to rewrite this, I have y over xy plus x over xy. That's the top. And then I have xy times x. What is that going to give me? xy times x. X squared y over xy minus, and then I have y squared times y. Y to the third over xy. Notice now that I have xy on all my denominators. So that means I can do what with it? Cancel. It's now gone. So that means on the numerator I am left with what? Y plus x. And on the denominator I'm left with? Good. Okay. So from here, I need to see if I can simplify my numerator or if I can simplify my denominator. Which one of these looks like it could be simplified? Top or bottom? Bottom. Right away, we know we can take out the GCF of what for the bottom? Y, because they both have one y that we could take out. So that means x plus y over y. If I take out a y, what am I left with? X squared minus, we're looking at what I highlighted in blue. If I take out a y, y squared. Okay, now looking at this new denominator, can I simplify this even further? Yes, what is that x squared minus y squared? Perfect square, so that means I have y plus x over y, and then I have x minus y and x plus y. So seeing this, we see that what cancels on the top and bottom? Good, this y plus x and x plus y. So that means I am left with 1 over y times x minus y. Which again, notice we did this problem above and we got the same answer using method 2. Okay. Any questions so far on method 2? Now let's look at the last problem for this method. Number 7. What's the first step we have to look for? Good, we need to make the ones fractions. So we're looking for that every single component in here is a fraction. So we had to make those ones fractions. Now I look at all the denominators. I have a k plus 1, a 1, and a k plus 1, and a 1. What would be the common denominator between all 4? K plus 1. So that means, do we need to change anything to this fraction and this fraction? No, because they already have that k plus 1. So what do we need to do to these two fractions? So if we multiply by k, we would just have the denominator k. K plus 1, because remember we're multiplying, so it would be 1 times k plus 1. So I'm going to do k plus 1, that we're multiplying top and bottom. Okay. And again, we're not doing anything to those first fractions because all we need to do is multiply by 1, which doesn't change it. Bless you. Okay. So simplifying this, we now have 1 over k plus 1, because that did not change, minus k plus 1 over k plus 1. Because they were both being multiplied by 1. And then on the bottom, we also have the same, that 1 over k plus 1 plus k plus 1 over k plus 1. So now that everything has a common denominator, what can we do with those k plus 1s? Cancel, because every single one is the same. So we can cancel out those denominators. And what would we be left with on the top? Good. 1 minus k plus 1. Do I need to put that k plus 1 in parentheses?
Yes.
Yes. Okay, what about on the bottom? 1 plus k plus 1. Do I need to put the k plus 1 in parentheses this time?
Not really.
No, I don't need to. Why?
Because it's all addition.
Good.
Signs are going to stay the same.
Good, it's all addition. So the only reason we put the first one in parentheses is because we're going to have to distribute that negative. So that means it's going to change the signs. So on the top, I have 1 minus k minus 1 over 1 plus k plus 1. So combining like terms on the numerator, I have a 1 and a minus 1. What's going to happen to those 1s? 0, so they cancel. And then on the bottom, I have a 1 and a plus 1. What is that going to turn into? 2. So we have negative k plus 2. Okay. Is this as simplified as we can get, or is there something else we can do? So we can't take the k's because the k on the bottom is being added to something. So if it was being multiplied, like it was 2k, then we could cancel out the k's. But since it's being added, we can't. So what do you think that tells us? That's our answer. The only other thing that you technically could do is take out a negative from both the top and the bottom. And when you do that, you would be left with k over negative k minus 2. So if you went that one step further and you circled this as your answer, that they're both correct. Okay, and that's taking out a negative 1. But you see it doesn't really change much of the problem. We still have a negative in there. The only time I would really take out a negative is if both the top and bottom have a negative in them. Because then we're making the whole answer positive. When we took out the negative from this one, we still had a negative answer on the denominator.
I've kind of asked this before, but in that answer right there, if you were just putting like the negative in front of the fraction, would you keep all the variables as they are, but then just move the negative to the front?
Yes, so if we had negative k over k plus 2, that is the same. And it's the same with the denominator too. If that negative was down here instead of up here, you would still take it out and it would all stay the same. Okay, so that was topic 15.